So another extremely important fact relative to petroleum, oil fields, is that apparently all petroleum is organic in origin. Until now, in modern times, we have artificial oil manufactured in a laboratory, and not in millions of years. The factory process that might take, I don't know, whatever it takes, weeks, maybe days, and maybe hours. There have been inorganic theories of origin in the past, but the accumulated evidence now is overwhelming that petroleum has an organic basis. The exact nature of the organic material has been as yet quite unsettled, but there seems little doubt that the vast reservoirs of organic remains, both plant and animal, in the sedimentary rocks constitute a more than adequate answer. The deluge once again appears to offer a satisfactory explanation. I call that plausibility, an explanation of the origin of oil, as well as the other stratigraphic phenomenon. The great sedimentary basins being filled rapidly and more or less continuously during the flood would provide a prolific source of organic material, together with whatever heat and pressure might have been needed to initiate the chemical reactions necessary to begin the transformation into petroleum hydrocarbons. Organic materials, hydrocarbon in nature, right? Recent studies indicate that certain dilute soap solutions seem to be associated with petroleum formation, in that these can act as solubilizers, being soluble, for the hydrocarbons in the deposit sediments, which, when further diluted with water, permit the dissolved hydrocarbons to appear as discrete oil droplets. Thus, it would seem that crude oil originates during the compaction of a sedimentary basin by virtue of the fact that sediment hydrocarbons dissolve in waters containing natural solubilizers and then come of solution as oil droplets. The composition of crude oil, as now understood, is consistent with this hypothesis. E. G. Baker, Origin and Migration of Oil. Different species or specific types of solution mechanisms appear to account for the different types of crude oils. Constituents for the solubilizers would certainly be available at many places during the deluge, especially in areas of heavy organic deposition of marine animal remains. The process of oil formation implies, too, that oil was formed over wide areas rather than in the relatively limited locations in which it is found. Interesting. Such a mechanism would lend credence to the suggestion that the source leads of petroleum are not necessarily unique accumulations of hydrocarbons in a limited area, but rather may generally be coincident with the area from which water is expressed into the porous strata that eventually form the reservoirs. The general picture of vast organic remains, somehow dissolved and transformed chemically into petroleum hydrocarbons, then eventually into reprecipitated as oil. Is basically valid and harmonizes well with the concept of catastrophic burial and dissolution during the deluge. Start with a huge amount of material, process it, and then it gets gradually accumulated. See, the process of gradual accumulation into oil pools and reservoirs is then from here on basically a hydraulic problem, not a matter of fossilized remains or certain specific things that are specific to certain rock strata and so on. If the entire world of organic remains of humans and animals, except for the 8, Noah and his ark and his family, is drowned we have a huge amount of material to work with, and it's going to be a matter of random and not a matter of a certain particular series of rock strata or whatever. It's going to be a huge amount all at once, a pile of original materials. Some end up in pools, reservoirs, others dissipated. So the oil droplets, by buoyancy, tend to rise up through the surrounding water because it's lighter than water, and thus gradually to accumulate at the upper surface of the water. The extent of this transportation and the amount accumulated will depend on the hydraulic gradients and permeabilities of the containing strata. This, of course, has nothing to do with the fossil contents, as I said, of the strata, and very little to do with the tectonic history of the region, except to the extent that particular formations, which are either permeable or impermeable, as the case may have been distorted in some way. These hydraulic processes have been continuing since the deluge, gradually concentrating the oil that was formed at that time, and soon after into traps. So we don't look for fossils, the geologists looking for oil, but we will look for those traps. We find certain pockets as a chance drilling or exploration of one kind or another, and we find a possibility, then we drill to see if we find anything. And rarely, but on some occasions, we find oil. But there is no reason at all to think that these processes may have required long ages of time to be accomplished. As already seen, even under some modern conditions, petroleum hydrocarbons can be formed rather quickly. More recently, a school of thought has developed which believes that oil formation may begin soon after deposition of the organic matter in the sediments. One of the surprising results of this study has been the discovery of liquid hydrocarbons in recent sediments from the Gulf of Mexico. P.V. Smith, Jr. Occurrence of hydrocarbons in recent sediments, Gulf of Mexico. Similarly, the traps that form the pools need not have taken long to form. Although no primary oil deposits are found in Pleistocene strata, it has been shown that certain of the traps found in earlier strata were actually formed during Pleistocene time, which, as we have already seen, is, in our framework, post-deluge. Now you have the container, but then the matter wasn't formed yet. An example of the Llama Hills pool in California, the oil and gas of this pool are in the Miocene Tremblor formation, but the fold is parallel to the Pleistocene rocks at the surface of the ground. This places the accumulation in late Pleistocene or post-Pleistocene time. An illustration of the short time for a pool to adjust itself to a change in conditions may be seen in the tilting of the Cairo pool in Arkansas. The tilt occurred within a period of 10 to 12 years. If it had gone on for a few years more at the same rate, the oil would probably have moved completely out of the trap. Thus, it's a kind of random thing. That's why it's rare to find it by following evolutionists or evolutionary theory. Thus, the time it takes for oil to accumulate into pools may be geologically short, the minimum being measured possibly in thousands or even hundreds of years. Now, this is a geologist who's evolutionist in mind, and he's just reporting what he observes. So, that's A.I. Leverson. The character of petroleum deposits and such information as has been accumulated regarding the origin and migration of oil harmonize quite well with the deluge hypothesis. This is a part of Dr. Patton's amazing studies. Great research he did. So Dr. Don R. Patton, in his wonderful tape and notes, a beautiful example of this phenomena is seen near Cookeville, Tennessee. in the coal measures. Coal there. This tree, standing upright in the sediment, actually extends through two cyclotherms. A cyclotherm is a series of 10 different rock units where we find coal forming. And this sequence, this series of 10 rock units repeats some 50 to 100 times. We have a tree going through it. Trying to explain those cyclic deposits by normal uniformitarian processes gets very entertaining. I think the tidal forces of a huge flood are much better at explaining the cyclic forces. But if we look at the picture and notice that we've got coal down near the bottom that extends through the numbers of layers up into another layer of coal above. What we're seeing there is a picture that demonstrates you can't form coal over hundreds of thousands of years. It has to be basically a catastrophic event that deposits this sediment and covers it and forms it into rock rapidly, or you don't get this kind of picture with the tree standing upright, well preserved from top to bottom in it. Actually, experiments with the formation of coal show, contrary to what we read and hear continually, does not take a long period of time to form. Consider the quotation from Chemtech of several years ago, giving the results of an experiment where a fellow for years and years to form coal in the laboratory and couldn't get it to happen. He says the reason, let me correct the spelling, is that he assumed it took a long time. But rather accidentally, he found out that he could do it if he did it rapidly. Presumption was, well, let's see if we can do this, quickly. Presume these kinds of conditions and reproduce them in the laboratory. Now we have synthetic oil. Same idea. He says a rather startling and serendipitous discovery resulted. These observations suggest that in their formation, high-ranked coals were probably subject to high temperature at some stage in their history. When that happens, now that's a possible mechanism for formation of these high-ranked coals, which could have been a short time, rapid heating event, 6 hours. George R. Dean, Dean of College of Mines and Mineral Industries, in Chemtech magazine, back in '72. Now these are not even in the geology books for college courses. By short time, he relates in the article, he's talking about 6 hours. With temperature and pressure, you can get coal formed from wood in just a few hours. And it doesn't happen slowly. Of course, you study the strata, the environment in which coal is formed, and you presume from what you can gather, which is reverse engineering without any observation capacity, because you don't have the time to sit there for 100,000 years, do you? The environment in which coal is formed, and you would learn that from the trees and from minute details and beautifully preserved fossils. The same kind of picture is seen when we experiment with the formation of oil. Notice that the quotation, synthetic oil, notice it can be formed in no time at all. Notice the quotation from the Sentinel Star in Orlando in '82. And we're doing this at Texas A&M, by the way. By this was reporting from an experiment in London where we are told British scientists claim to have invented a way to turn household garbage into oil suitable for home heating or power plant use there. Same kind of idea. And we are told that we are doing in 10 minutes what it has taken nature 150 million years to do. Well, maybe you ought to reverse that idea, because you weren't there 150 million years ago to watch it go. Why don't you figure out that nature figured out a way on a larger scale to do it as well? The worldwide flood. Noel McAuliffe from Manchester University's Institute of Science and Technology. The article goes on to say that the oil is comparable in quality to Middle Eastern crude. 10 minutes, but it took nature 150 million years. Of course, nobody sat down and watched it happen. See, that's the point. You can't reverse engineer something that's not scientific, because you can't, scientifically, it can't be scientific. You can't observe it and then falsify